Let's calculate some examples of the derivative of a function given this definition. So for example, if you have a straight line, then this should have a derivative of 2, because the slope of this curve is 2, and it's 2 no matter where on the curve we are. So this is the local slope. So that of course should then be equal to 2. So let's see if that's the case. So we calculate from the definition, then we first have to calculate f of x plus h. That means we have to put in x plus h here. And that will give us this one. Then we need to subtract f of x, and that stands just here, so just read it off. And then we need to divide by h. Simplifying this, we have multiplied in 2. Here we see that 2x cancel, and also a 3 cancel. So what is left is 2h divided by h. And here we can simplify this to 2. Now we should take the limit of 2 when h goes to 0. But 2 is just a constant, it has nothing to do with h at all. So the limit of 2 when h goes to 0 is just 2. And then we arrived at the derivative is equal to 2. And that's just what we expected, that it should be equal to the slope. And more generally, if you have a straight line, ax plus b, doing the same calculation, but with ax plus b instead, you will find out that it will be equal to a, just as you expect that the local slope should be equal to the slope of this, since it's a straight line. If you have a constant function, meaning that the function is the same value for all x, then it looks like this. So we see that the slope in this case will just be 0. And as we just stated, we see that this is a straight line with slope of 0, so this must be equal to a, which is equal to 0. So if we take the derivative of a constant function, the derivative is 0, because the slope is 0 everywhere. So what is the derivative of a curve that is not straight? For example, a simple example is x squared. So what's the derivative of that? Then, using the definition of the derivative, we see that we shall now put in x plus h into f here. So we replace x with x plus h. And then we have f of x, which is just x squared. To simplify this, we can use the square of a sum rule. And then we get this. And then we need to take away x squared. Here we see that x squared will cancel. Which gives us this. Here we can simplify by dividing by h on both. And that will give us this. Now we should let the h go to 0. take the limit of this when h goes to 0. 2x has nothing to do with h, but h here then should go to 0. So this becomes 2x plus 0, or just 2x. So we see that the derivative of x squared is equal to 2x. And that means, for example, if we want to find out what is the derivative at this point. So let's say that this is x equal to 1. Then the derivative is just the slope of the tangent. And now we know that the derivative is given by 2 times x. So the slope of this one is equal to 2 times 1. That is 2. So if you take a point x equal to 1, you find out that the local slope is equal to 2. In the same way, you can find it out for every other point.